Okay. For the first, I would like to tell some words about the task necessary to solve for the hydrocarbon production doubling in 3 or 5 years in western part of Ukraine, and also maybe the near countries that locate in the same region as we stay today. What is the task? For the first task, to increase drilling success rate from 52 to 86%, to increase company profit from 43 to 150, and to increase the number of commercial wells by 20%, to increase the commercial hydrocarbon production rate in 91% of the cases. What it is necessary to do for solving of this task? It's necessary to before the drilling of the new well, and that the well will be the commercial. It's necessary to map hydrocarbon commercial pools. Do not drill the well outside the mapped pools. Do not drill deeper than the deepest mapped pool, and to drill a new commercial well inside an area with the highest expected recoverable reserves and production rate. Many people ask me what is the difference between the pool and reservoirs and other. I'd like to define some definitions. One of them is hydrocarbon pools, is definition from the oil and gas industry as a geologically defined area containing a single reservoir or connected group of reservoirs, all sharing a joint pressure system and ready for drilling. The properties of the pool is the same as properties of the petroleum system that was developed by Professor Bernard Tissot in 1978. Expanding of this definition, I propose some different definition. As I name it, a conventional hydrocarbon pool is a pool with a porosity, permeability, hydrocarbon saturation, recoverable reserves, and a production rate that together are higher than cutoff value, making future drilling and production commercially viable. It is the most important thing that all of these properties must be higher than some cutoff value and for different, and also very important that this object or object that we name as the commercial pool is isolated as named in hydrocarbon pool definition. What is the main uncertainties of existing paradigm of the commercial hydrocarbon pools mapping? Of course, all companies today use a petroleum system as a main stream to prepare their pools for the exploration. And this process have some steps. One of them is a source rock. The next step is understanding of the location of sedimentary basin. This is a geophysical exploration stage. And only the fourth stage, we see appraisal and production after the successful drilling, where the conventional pool is a pair, the conventional pool as I define in my definition. And the last step of the analysis is reservoir analysis, when beginning the production of oil and gas. What are the restrictions of using of this paradigm that you know and may see after the drilling the wells on the different part of the well? The most of them is a large number of dry holes and high risk of unprofitable projects. Is the result of this that many companies stop their activity. Why I said about this restriction? Because if we analyze information from the APG wiki seed, we see that, and also following to the classification of exploration drilling and statistics that use in SPE, we see that any kind of pools that necessary to explore and to drill have a medium or high risks of the drilling and success of this drilling. You see in the table for USA and Canada, and also is the same result or the same level of successful rate we see on the analysis that printed in the paper, Mr. Alexey Milkov, that analyze result of 600 drilling of 600 wells in different regions in the world, and for the time for 30 years, at the time after the proposing the petroleum system and using it for the prepare objects. And also we add the information from the drilling of 152 wells in Ukraine. What is the conclusion of Professor Milkov was that average probability of success of the drilling of the discovery of the new wells is 52%, and for 30 years, as you see, the time of analysis was 30 years. This level of success is not changed or not higher. What we must understand that object that we necessary to study is some those very different types is a structural and stratigraphic, and also stratigraphic pools. And more important that this object is isolate local object in the 3D space, and our main task is to prepare this object for the future drilling and to increase the probability of success of this future drilling. What is the properties of the commercial hydrocarbon pools? As I said in my definition, this object must be isolated. This object must have a porosity, permeability, saturation, recoverable reserves, and production rate. We said about the last two things that is important, especially for the commercial pool. What is the main properties for the estimation of the recoverable reserves? Is porosity and saturation. For the mapping or for the study of this kind of objects in the 3D space, we necessary to have some geophysical property or physical property that will be better correspondence to the list of properties of the commercial pool. This type of property is, and if we take a structure of the rock that we that is the object of our study. This consists from the matrix of rock, and porosity space. In porosity space, we have a bond water, free water, and hydrocarbons. If we see on the list of the properties of commercial pool is very similar, and the rock of the density of the rock is the most best property that we may use for the mapping, for the corresponding to the commercial pool. What is important? If we take the rock density for the commercial pool rock or for the host rock, you will see that the density of this rock will be different, and the density of the pool rock will be always lower than the density of the host rock. Other important question that necessary to understand, if we have the possibility to map the changes of the density in 3D media and what minimum reserves and what is the anomaly we will see on the day surface for this study. We analyze the anomaly of the minimum anomaly of the gravity field as a anomaly as a resolution or accuracy of field gravity CY. Is today digital equipment is 7 milligauss we have. If we calculate the mass of the reserves and our reserves that we will explore is a mass, have a mass, and if we calculate the amount of mass that correspond the gravity field on the top of 7 microgal, we will see that it's for the if we see that attention to the depth, this mass will be higher and higher. And what we see that for the depth from 0 to 5,000 meters, the amount of mass is lower than 1 billion cubic meters of gas. From 4,000 to 8,000, it's a change from 1 to 4 billion cubic of meters, and from 8 to the 11, it's change from 5 to 8 billion cubic meters. As you see that mapping of the explorer of the objects with lower reserves is will not conventionally effective, and this curve is show that all types of all amounts of reserves may be mapped, and they produce the anomaly on the day surface is an out to study it by gravity data. Other question that often asked is understand how we may separate different objects from different depths. It's very simply on the diagram you see the view of the gravity anomaly for the different depths. It's point with 500, 3,000, and 10,000. You see that the thickness of the width of this anomaly is more low for the object that place on the low depths, and for the big depth, this thickness is higher, and this object is separate in the field. And when we map this object, we use not the data in the point under the object, but we use data on the whole surface of the web. Of course, what is the steps of innovative paradigm of the commercial hydrocarbon pool mapping? It's beginning from the high precision gravity CY. Next step is 3D real density model building. After this, when we have a real or actual density model in the rock, in the 3D media, we have possible to calculate the 3D hydrocarbon reserve density model, 3D production rate model, and estimate the recoverable reserves. What is the advantages of using of new paradigm for conventional pool mapping? For the first is direct mapping of the conventional pool. It is low uncertainty because the density of the rock is only one unknown in this siege. High geological probability of success, and the most important, the small amount of dry wells, and possibility to regeneration of old and initiation of new production projects for all types of pools and depths. What we we will have the probability of success of the applying of this new paradigm in exploration process. We analyze the result of drilling more than 84 wells that were drilled on the regions where we previously mapped these commercial pools. And also in these wells, we provide 176 well tests. Analysis show us that 61% of the wells were drilled inside the before mapped pools, and also 42% of well tests were provided also inside in this pool. From this well, 86% of the wells will stay the commercial, and 79% of well test also was finished by commercial production. Using all this data, we said about the probability of success, geological probability of success of new paradigm as 86%. If we back to the scheme of classification of exploration drilling, you will see that all kind of pools that are ready for drilling, as defined in the definition of hydrocarbon commercial pool, will have a high probability of success, is higher than 75%, and have possible to provide the new production projects using this paradigm. When we said about the probability of success, very important to understand what the accuracy of the prediction of 3D of the density in 3D media. If we have a much drilled well and possible to take the data before direct from this well logging, we compare our models and compare the data from the wells. You see that 81% is a correlation between the model that was built before the drilling and the curve of the density that was measured after the prediction. Also, it's easy to understand that if we have a possible to map the location of our pool, and we have map the density of reserves, hydrocarbon reserves, we have a tension between the amount of production rate and between the density of hydrocarbon reserves. If the reserves is higher, as the production rate will be higher. We use this attention and see that on the 11 object, that in the 11 wells, where we predict before the drilling the level of production rate, and with 92% correlation between the prediction and the real production rate from the well. Why we have possible to expand the number of commercial well and give the additional 20%. We take as example data for the result of drilling on this 84 well that I showed you before it, and we propose if the company or chief geologist will decide to use our prediction and the outline of our commercial pool as an information and not drill the well outside these pools. It's give an additional 60 wells and show 20% of additional commercial wells expanding of the budget of the drilling. We're using the same budget, and 20% of the new commercial well is very high result. Also, if we will calculate the profit from the incorporation of this new paradigm, we see that going from the probability of success of 50%, that is a traditional wildcat drilling that give $20,000 for the one well, we have possible to increase profit on 47%. Is for shallow well with cost of the drilling, complete drilling, and $8,000. And for the wells that may drill or will drill on the sea, where the price of complete well is $160 million, this profit is higher than 100%. What is the workflow of the commercial hydrocarbon bull map? It's use of all available geophysical and geological data. On the scheme we show as a direction of arrows that show direction of movement of the information. We use well log data, 2D and 3D seismic data, petrophysics, core data, constraints and uncertainties, and well log information. On the base of this data built an initial model that quality is that what in the qualified is associated with all available data. On the next step is we provide a 3D inversion of the well log and gravity data, and build a final 3D density model that give us in the future possible to calculate of all kind of type of the properties of the commercial pool, and calculate the hydrocarbon reserves and also initial production rate. Very important to show and to understand how we build the 3D model. It consists from two steps. On the first step, we build a 3D initial structure model. We use all, as I said, all data that characterize the geometric parameters, properties of our Earth. It's day surface it may be the day surface geological map, a geological section 2D, and regional geological boundary 3D, seismic section 2D, and seismic surface 3D. We incorporated in one model and have a priority for this, and this give us possible to build the complete 3D model and the correspondence of all the data that you see on the scheme. It's a best 3D model that may be built following to available data. On the next step is necessary to fill the beds by the densities. For this, we also use all available data, beginning from the core data, well log data, sonic log, that we recalculate in the density. It's maybe the 2D or 3D density models, and regional density and depth on depth and lithology and age dependent that have place on the region where we study. This also have a priority of using all this information to build a best model that on the last step this model may be represented as a cumulative density well, where in which you see that upper part where the well were drilled before our work, we have possible to calculate the density from a sonic log, for example. Other red dashes show us correspondence of this data to the core data. and other part is change in Howe density, which was driven from acoustic log from the well outside the region of the area of exploration, and the black curve is a change in Howe density according to the regional density petrophysical data. On the last step, we have two kind of models. One of them is fulfilled by the well log data. It's upper part of the screen, and after this, where the beds where we have not where there were no the well that was opened, these beds, we incorporate the information from other kinds of information, and build a 3D model that you also see on this slide. The next step is inversion, 3D joint gravity and well data inversion. It's realized according to the mathematical method of inversion that was developed by our team, and we have a special theory that show us that we have possible to take a unique and stable solving of inverse problem that incorporate or in use of these all kind of available data that I described before it, and on the swatches the information. This gravity field, as you see, its initial 3D model that I show on the previous step, and well log data in all the well there where we have well logging or other kind of information. We control the deviation between the calculated gravity field from the model and the measured gravity field that we used as complete Bouguer anomaly field. And also we check the well log, the misfit between the well log data and our model. What is important to understand that initial model, it is a model that today propose as a result of interpretation of modern 3D seismic data. For us, it's only initial model, and we propose to expand, to change this model from one side that this model stay correspondence with seismic and other geological information, and from other side it's correspondent with measured gravity field and also with the density that we have in the wells. The process of finding of the meaningful model consists of some steps. On the last step, we obtain, we said, is a geological meaningful model. What is the aim of geological meaningful? Is a model that mostly corresponds to all available data on today for this seismic data, geological information, well log data, and also with gravimetric field. As I said, that the object, our object, must be isolated and must be have a main property that inside this isolated object, the density will be lower than the sum cutoff value rock density, and also after this, the density anomaly is changing between the rock density and the cutoff value, give us possible to calculate, to estimate of all properties of the commercial pools. In this slide, you see an example of density log in the Runevshchina gas field, where the blue line show us the changing of density, and the yellow line is hydrocarbon saturation. and the cutoff value that divide the rock of the commercial pool and other host rock is 2.1. How this object view in 3D? You see that the isolation is a low density area is you see as a yellow region. After this object, the outline of this, as we said, the object must be close, and we outline this object and see the border of the possible commercial pool. You see it on this slide, cutoff on the cutoff rock density value. This cutoff rock density value is not the same in the old model. It's separate in different layers and different pools in one layer. As a result, we have an outline of the pool. After this, we go to the estimation of the properties, the porosity and saturation, and after this, have possible to calculate the reserves, the recoverable reserves, and the density of hydrocarbon reserves. Why we have possible to do it? We have information about the about the gas or oil saturation and the property of the gas and oil in the depths, in the pressure and temperature. But from the also we have a density of the water, and what is important to calculate, to estimate of the porosity and saturation. As we said, as we said in our definition of commercial pool, the porosity and saturation must be higher than cutoff value, and as a result, the porosity and saturation must not maybe different any value have, but they will have a value from the space of porosities and space of saturation that higher than cutoff value, and also that higher than cutoff value. We have a uniqueness equation. We see the line is a change of the porosity and saturation according to the density, the same anomaly, density anomaly, will all of this point. But if we take the data from the wells, you see the gray bubble, we have possible to directly finding the real density, real porosity, and real saturation that corresponded to core or well log data. Also, on this slide, you see a tension between the density anomaly of reserves, density reserves, and initial production rate of the well. Also, you see the attention about each I said in previous slides. After the description of the new paradigm that we proposed, and we use it to explore for the many objects in the Ukraine. It's more than 90 projects we realized, we completed, and also we work more than 30 years. I'd like to show you some slides about the history of incorporation of applying of this paradigm. For the first, it was the regional work of the studying of Carpathian Mountains, Carpathian region, oil and gas region. We finished it in 2003. It's include building of the geological cross-section through the whole western part of Ukraine. And after this calculation of the representative of the density on this profile, on this cross section, And after this, we built a 3D model. It was not a real 3D model. It was a composite 3D model, but this model give us possible to, for the first time, to see how the oil field, the regions with oil field distribution, and presented in the 3D model. You see two kind of the outlines. That one of them is a region with oil production fields, and other kind is Borislavsko-Pokutska region, and other part is Belchevodetska region, where concentrate the gas field. And we see of this kind of object on this on the slice of the level of 960 meters is for Borislavsko-Pokutska region, and for the depth of 4,960 meters for the oil field. Also, we see on this slice a new different region. We mapped it on the this map. We put it in this map. Is a new prospective zone analogous of unknown productive area. We see the area that corresponds to the gas field on the anomaly, about the value of anomaly, and also we see the object as corresponds to the oil saturation or concentration of oil fields. Other steps of our regional study of Carpathian region was detailed detalization, also on the base of building of 2D cross-section, geological cross-section, on the different part of the Carpathian mountains. It consists of the eastern part, western part, central part, and also a special study of Transcarpathian part of our territory. This also give us possible to see how view the changing of density and how view the our geological model in this 3D model, in this 3D media. What is important that many discussion we have about the location of the junction between the Eastern European and Western European place. As a result of our work, it was through mapping of the direction in the 3D, in the 2D space, and also we see it on our profiles where it's directly mapped. What is important that changing of density is very important for understanding of not only the commercial pool location, but also the geological structure, location of the faults, of blocks, and for some regions, we see the intrusion of mantle plume under the sedimentary covers. What is the result of this work is a map of the distribution of local areas where may be placed a commercial pool that is the information about the future location of the new licenses and new exploration projects. We have some result. Now I will like to show you the detailed exploration projects of the commercial pool mapping on the local areas. One of them, it was in region of Debrivska-Solotvinska gas field in Transcarpathian part of the Carpathian region. We finished or complete this project in 2004, where the well 22 on the Debrivska region was drilled with the gas production, and after the building of 3D, providing the 3D seismic survive and building of the model, we map the location of the commercial pool The result of drilling of two wells in 2011-2012 show that one of them was drilled, two of them was drilled in the central part of the structure, and it was dry and was dry according to our prediction. And other kind of well was drilled on the Solotkina field, where we predict that the commercial pool is located in the central part of the anticline, and this well take 61,000 cubic meters production. Other interesting object in the Precarpathian for a deep is Mikulichina oil field. We also built the 3D model of this object in 2004. From today, on this region, in this field, were drilled 7 wells and provide 8 well tests. Result of well tests show that the actual probability of success for mapping of commercial pool, according to our model, is 87.5%. Only the well number 6 was drilled before our project, and all this red point is a successful drilled well, and that corresponds to the outline of this commercial pool was mapped in 2004. Other kind of the example is one of the field of lessons that we studied in the Precarpathian for a deep in Krosno zone. It's the Zdenievo license, where we see that the history of changing of geological cross section. On previously, the part of the Naples what was presented as Paleogene, Cretaceous and Paleogene Naples, but our drilling the well 3 in Lutnia field show that it's this part of this Oligocene Naples only, and we use the new model for the starting of this area following to the result of drilling of this well. This gives us possible to understand how changing the density in the depths. We see that the 5 Oligocene naps on this region, and in this field was drilled the well, and unfortunately the location was outside of the predicted area of low density and possible as commercial pool. What is important that the result of well logging in this well show that a good correspondence with our 3D model. You see 3 types of information that were taken is core data, is density log data, and our information from our model. The next is object in the Precarpathian for a deep is mapping of the commercial pools in the Neogene in the central part of this region, where we provide the gravity survive, and also you see the process of inversion from the initial model to the last model. Is model be better. What is the main step of changing? For the first step, we change the location of top of Paleozoic. The next step was changing that mapping of the salt dome on the sedimentary part, and other was on the last step was prediction of the change of density in the Neogene, and that was proposed for the drilling. How view the 3D model of today view on the 3D model of hydrocarbon pool properties? Is the rock density, is the porosity, gas saturation. You see that on this step we left only the part with correspondence to commercial pool, and other part of the rock are not interesting for future drilling. Is permeability, effective porosity, and pressure. And most important is 2 kind of gas reserve density, is because it's directly show us how gas we have in the 1 cubic meters of the rock, and also the initial production rate, and view on the 3D media of the 3D outline of 3D shape of the commercial pools and location of proposed wells. What is the result of the drilling on this field was that it was 2 wells was drilled. One of them were located outside the mapped pools, as it was a dry hole, and other one was drilled inside. It was a commercial production well. What show the well, dry well? That give us possible to correspondent compare the model and result of drilling, and you see that as I show that 81% of accuracy. And why this well was not produced the gas? Because the gas commercial pool is located other side, and well not open it. And in our prediction, there is no any information about saturation and density of reserve. The next well was drilled inside the commercial pool, and you see our prediction before drilling, where we predict the level of gas saturation, and also we predict the porosity. You see the green curve is a changing of porosity in our model, and blue and red color is the level of porosity from the result of well logging interpretation. It's result of well testing. You have a gas and water with conventional level of production. As you see, in one and other case, we have a 100 probability of success. In previous ones is a 100 success of prediction of dry zones on dry rocks, and in this well, in this kind, we have a 100 probability of prediction of gas saturated rock. For the new, some words about the new direction of activity for decreasing of gas and oil production in Carpathian region. We see on the Mesozoic and Paleozoic. In this map, you see the correspondence between Ukrainian and Polish part of this type of the sediments. You see that have some hydrocarbon pools in Jurassic, 8 in Paleozoic, and 1 gas in Cambrian. We see the same object in the following to our result. We see the same object in the Ukrainian territory. It's the stars in the location of today open the field, gas and oil field, condensate field, and the bubble is the location of the prospective area that we see. What for the first, I would like to talk about the Jurassic. We have 4 gas fields and 1 oil field in Ukrainian part. The main important is Lapushna oil field that located in the southern eastern part of Ukraine. Many years, many scientists finding the new Lapushna in this region, but unfortunately, the result is not successful. We, as a result of one of our exploration, was mapping of the object in the Jurassic sediments that directly presented as a low density anomaly in our cross section, and also you see the same representative of this anomaly in the combining of seismic cross section and density cross section. And this object view, as you see in 3 media, what is important that is more accuracy correspondence to the Lapushna field, and is located on the depth 1,500 meters. And as we have possible to predict or estimate porosity saturation and density of gas reserves, we have possible to estimate the expected reserves of this object. Is one of the examples that after the drilling of the well and opening this object will give possible to back to the prospective region on the Jurassic. Other kind of the sediment that also have production in Polish part is Cetynia gas field in Cambrian. Unfortunately, the result of drilling of the wells on the Cambrian in Ukraine show that all this well was water production, and for our view on this situation, that we do not know a method or technology to find the object in this region. As one of the results of our exploration project was mapping of the commercial pool in the Cambrian with gas reserves 1 billion cubic meters of the gas. And the last ones that I was through said, it is Silurian shales. You know that a big territory of the Ukraine is Alaska block, and during one of our study, we see that in the Silurian shales we map the region of the low anomaly, low density, and according to the successful of this rock is the tension between the level of density of the rock and level of TOC. And as a result, we map the region with probability of production of gas in the Silurian shales. You see it. And we also estimate the reserves of this near the 4 billion cubic meters of the gas. And also we have a possibility, we develop the special technique for estimation of the initial flow rate from this well. Also, this well is waiting for the drilling of the first well. If we'll open, also it opens the new direction of activity in western part of Ukraine, or not only in Ukraine, but also in the Poland, where also the same sediments have place, and also maybe Romania. As now I finished, I would like to back to my previous first slide and show it as a conclusion that today we have possible to doubling the production of the gas and oil and in the Carpathian part, Carpathian oil and gas region on the base of the applying of the new paradigm for the commercial for hydrocarbon commercial pool mapping. This applying give possible to increase the drilling success from 52 today level success to 86%. As a result, this give possible to increase the profit of the oil companies that will drill the well with profit from 43 to 180%. The 20% of additional commercial well will be take place, and what is necessary to do? For the first, it's necessary to map the hydrocarbon pools, to not drill outside the mapped pools, do not drill deeper than deepest map pools, and to drill a new commercial wells and discover the new fields on by the first commercial wells and made it as a exploration well, production well, because the level of success is associated with level of success of production wells. Thank you for your attention.
Thank you. Thanks a lot for this presentation. Dear colleagues, we are almost run out of time. We still have time for one question, probably. So if someone have a question related to what we just seen, please ask the question. This is a unique opportunity to ask an author of this interesting methodology, how it works, maybe somehow related to your fields you work with. Okay, if there are no questions, I believe that later those questions will definitely appear. Yes, please. Yes, Nicoleta,
yeah.
you have a question.
Thank you very much, Mr. Petrovskyy. I'm Nicoleta from Romania. I'm reservoir geologist, more on production. I'm only curious, in what years were the 2D seismic profiles recorded in Ukraine? I'm curious just because we have profiles from 1950s.
No. We have examples of experience to use of the seismic data from different time. It's from the last century and in Carpathian mountain. But on our last project, some seismic surviving was provided in 3D seismic also in Carpathian mountains and 2D seismic. And we use it, no 3D, I'm sorry, it's now only finished by one of the company. It's 2D, but it was measured not far for a time, it's last year.
Okay. And in the northeast of Ukraine, we are in the Flysh zone, correct? I'm wrong? And in that area, we have the yellow part, yeah? In that area, we have the information from, probably I'm not okay, from Jurassic.
Yes, we have presented Jurassic in our
and Cambrian, yeah. I see. Because we don't in the Flysh in Romania, still we don't have there any information. And I'm curious, what software are you working on? Because doesn't look to be Petrel software, or it's something new. I don't know.
It's this often question that ask me my colleague that we use Petrel. No, we developed the special our own software for the building of the model, for inverse problem solution, and for the representation of the data in 2D and 3D media also.
It's only in Ukraine, so it's something.
Yes, we stay in Ukraine, in Ivano-Frankivsk. I live directly in the region where about we talk about now.
Okay, and my colleagues, reservoir geologist production for 3D models workflow in the company, they are using the software workflow from Schlumberger. I'm just curious, I'm asking.
We solve some different problem because software is Petrel is a good software. I have no concurrent of this software. We solve other problem. Petrel a good calculate on the step when you are open the fields and give much well of data and give possible to build some model of porosity, permeability, and saturation. Some model. It is a model. It is not a real model. We add to this model or change this model according to the gravity data. As I said, I show you that the gas saturated rocks is low density, and we must check when you finish your model. You must check it to the correspondence of gravity field, and we have possible to do it. And when you see that is not correspondent, it's necessary to change it. We also have possible to change it. I would like to one point, but we have a project in Ukraine. Is we have a Dashava gas field before many years ago. Now is a underground storage. We provide the project in monitoring of the gravity monitoring of this gas storage. We have a 4-month measurement of gravity field. It's view the dependence between the level of gravity field and changing of density of gas. It's according to the changing the pressure. I'd like to said that I put on the first slide the QR code of our seat, as there are many information about our technology, about the example of solving the different problem. Some of them is the understanding of situation on the gas storage. And if you see, we see that is not a concentration of gas outside the anticline structure, but we see that there are some localized region, shapes of bodies where gas go when we increase the pressure, and from which gas moving when we decrease the pressure. It's not correspondent with geological stratigraphic structure.
Thank you a lot. Nice, very good.
Thank you. We are like 5 minutes behind the schedule, but maybe if someone else have a question, let's take this unique opportunity and ask Professor Petrovskyy. Any other question? Okay, then I believe that's it for today. Thank you a lot for presenting, Mr. Petrovskyy. It was really interesting for me, as for the person who worked with Schlumberger software for a long time. It was really interesting to look at something new and to learn a new interesting approach. And I'm more than sure there will be even more interest in your approach once we place your lecture on the YouTube. So all those people who somehow missed this lecture today will be able to watch it later. Thank you. Thank you for your time, and thanks to all the people who joined us today. Thank you.
For the finish, I would like to say thanks all who hear me and view me. And if you will have a question or ask, please contact with me directly, and I will help, show you and help you to solve your problem very efficiently and in a short time.
Thank you. Thank you.
Bye-bye.